Hey, GED students, if you struggle with polynomials, you might be one of those students who really struggles visually to tell what's going on. So what I wanted to do today was do a side-by-side comparison of adding, subtracting, and multiplying polynomials. Okay, so first of all, how can I tell what's going on here? Well, it's all about what's happening between the parentheses, not on the inside, but between the two sets of parentheses. So let's go ahead and take a look here at my first example, the adding example. And so you might say, well, Kate, what the heck are you talking about? A polynomial. Polynomials are basically just, mathematical expressions that can have more than one term, more than one thing adding or subtracting in it. So this particular expression here in the parentheses has three terms to it. It's three things that are adding and subtracting. It is a polynomial, and you can see there are different kinds of things. The first one is an x squared term. It's some number of x squareds. The second one is an x term. It's some number of x's. And the last one is what we call a constant term, meaning a plain old number, constant term. You don't have to know these vocab words for the test, by the way. I just want you to know what I'm talking about as I talk today. Okay, so I have this one polynomial, and we can see that between these two sets of parentheses is this plus, and then we have this other polynomial. Again, multiple terms adding and subtracting, multiple things adding and subtracting. I'm looking at a polynomial. So these two polynomials are adding. Compare that to this one, where we have two polynomials subtracting, or this one, where I have a polynomial shoved up against another polynomial with nothing between the parentheses. We know when there's nothing in between us but parentheses, we're all shoved together like that. That is multiplication. All right, so now that we can tell which one's which, let's go ahead and try some of these. So I have really good news if we're going to start with addition, because basically it really doesn't matter here. There's no change with additions. We're just going to drop the parentheses. When there's just a plus in between like this, when we're just adding, we don't really need these parentheses. I'm saying add all of this number and all of that number. Okay, well, it's not serving really any purpose here. I don't need to keep these grouped. This order doesn't really matter. And so I'm just going to totally drop those parentheses with no consequence. And that's great, because addition is not going to affect anything that's adding or subtracting in these parentheses. And so now it's not really polynomials anymore. This should look really familiar to you. We're combining like terms. Remember, in math, ever since the beginning of math, I don't care whether you're talking kindergarten math or high school math, we've only ever been able to add and subtract the same kinds of things. So how does that play out in algebra? Well, in algebra, they have to be what we call like terms. But again, all that means is the same kinds of things. So like x squared terms are going to combine with other x squared terms, and plain old x terms with other x terms. And then those constant terms, remember that word? It means just regular numbers. Constant terms will add with other constant terms. So I'm going to pick up some colors so you can see what's going on here. This all by itself, 2x squared, is my first term. It's my first thing adding or subtracting. And I can only combine that. It's not because I'm not telling you how, guys. It's literally, I can only combine that. There's not some new ninja math you're going to learn that's going to teach you how to do it some other way. I can only combine this with another like term, so another x squared term. So let me move over here, and this is an x squared term. Notice something. Notice how I box it with the sign in front. I didn't just box x squared. I boxed plus x squared. You really need to communicate what's happening here to yourself. Okay, that sign in front belongs to the term. It tells you what that one term is doing. Okay, so 2x squared plus another x squared. Guys, a lot of students get all really weird and confused about this, but I remember that coefficient, that number in front, so the 2 in this case, just tells you how many of something I have. So I had 2x squareds, and then I want to add another x squared. It's just like if I had two apples, an apple and an apple, and then I add another apple. I'm just counting up. So if I had two apples and I added another apple, I'd have three apples. Well, same thing with x squareds. If I have two x squareds and I added another x squared, I'm going to have three x squareds. I had a student say to me, I don't know how to do this in my calculator. And I'm like, well, you didn't really need a calculator because you know that 2 + 1 is 3. You're not going to be able to type this entire expression with all the x's into your calculator. Your calculator doesn't do algebra. Your calculator does arithmetic. But if you forget 2 + 1, you could type that part into your calculator. But most of you guys know 2 + 1, okay? But you have to handle the x squared portion, okay? Your calculator can do the numbers. So if you get ugly numbers like, I don't know, 3/4 and 9/7, put that in your calculator. But you have to handle the algebra, the x's. All right, cool. So I combine my x squared terms. You say, well, what do I do next? You just keep going that way. You're just gathering together like terms when you add and subtract. Okay, so -3x, that's a plain old x term. I can only add and subtract the same kinds of things. So go scanning here. Do you see any other plain old x terms? We keep looking and absolutely, there's a -5x. Now, you could also read that as -5x, but I'm saying minus because it tells me what to do with the two numbers. I have a -3, and from that, I'm going to -5, and that's the part you can put in your calculator, because honestly, you guys tend to struggle with negative numbers, and I'm thinking hard enough about my algebra already. I don't need to rack my brain about negatives and make dumb mistakes here, okay? So I typed that into my GED calculator. -3 - 5. Now, that actually could throw a lot of students, so let me just show you. Because when it's in front of the number, you got to use the negative key down at the bottom, the one in parentheses. But when it's between numbers, that's when you use the minus key that's over on the right. So -3 - 5. Put that into your calculator and it'll tell you -8. But awesome, don't stop there. Remember, your calculator deals with the numbers. You deal with the algebra, guys. -8 what? -8 pumpkins or peanuts or X's or Y's or J squareds or what? So what kind of terms were we adding and subtracting? They were X's. We were counting up how many X's we either have, or in this case, we owe. If you think about it, it's negative. And so it's up to you to realize what you were counting. So -8x. Now let's move on. We also had some constant terms. Remember that vocab, guys? What did I say constant terms means? Again, you're not going to get vocab test on your GED, but you need to know what your math teacher's talking about. Constant terms are those plain old numbers. So I had a +5 and a -7. Now, since I'm going to put the two of those together, I want to read that negative as minus. So I'm going to do 5 - 7. Again, if you do it in your calculator, 5 - 7. And you'd find out that that was -2. So can your calculator do it? Yeah, I mean, the calculations, the number part, but you do the algebra. Okay. Now, right here, slow down, because you have to understand something so important right now. And that it is time to stop, y'all. Please, 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 please stop. The only math we have left to do here is a subtraction. And I told you, you can only add and subtract like terms, the same kinds of things. I love you guys, but I want you to imagine that you got this number as an answer when you added in math class. So you had added up some numbers and you got 382 as an answer. You wouldn't then sit there and add the 3, the 8, and the 2 together and say, hey, no, wait, one more step. 3 + 8 + 2 is 13. Wow, I'm a mathematician. Can't do that. Why? Because those are different kinds of numbers. That's not 3, that's 300. And that's not 8, that's 80, 8 tens. And that's 2 ones. They're not the same kind of thing. They can't add up. All they can do is sit next to each other. Well, we have the same thing here. This isn't just 3. This is 3x squareds. This isn't just -8. This is -8 x's. And this is just plain old -2, yes, but these can't combine because they're not the same kind of things. You are literally just done. You're done. So many students think like I'm just holding back something from them. Like I'm going to teach this one day when they get smart enough. Like if they get smart enough, they need to know how to do this math. No, there's nothing to do here unless you know what X is and they didn't tell us. This doesn't get any simpler. Okay. This won't get any simpler. Breathe. Have a cup of tea. You're done. Or as my daughter says, you're done. So now let's look at subtracting. Almost the exact same thing because the rules for addition and subtraction are pretty much, two sides of the same coin. So we're not going to see a lot of change, but there's one big thing you need to know, just one difference between addition and subtracting. And that has to do with these parentheses. Let me show you what I mean. What I say when I'm putting this whole thing in parentheses, and then I put this whole thing in parentheses, okay, is that I want you to take all of this, okay, I can take all of this, and then I want you to subtract not just one thing. I want you to subtract all the stuff in this parentheses. That's the difference here. We saw some pluses and minuses on the other side, but the minus wasn't in front of the parentheses. I wasn't saying subtract an entire group. When I saw a minus sign, it was just like in front of one thing, like minus just this 5x. Here, with this minus shoved up against the parentheses, I'm literally saying subtract the entire group, the entire group. Now, how do we do that? Well, when you subtract, signs change. Let me show you what I mean. Do you see how there's nothing out front of the first parentheses? I see nothing out front there. I'm not doing anything with that group. I'm just going to drop the parentheses. 2x squared minus 3x plus 5, no changes, just drop the parentheses. But this one says, I'm minusing this entire grouping. Now, a lot of you guys will just give the minus to the first number. You'll say, oh, hey, it was an x squared. If I minus x squared, I'll get negative x squared. But then you stop right there. That's not what that minus said. It was shoved up against parentheses. It says minus everything in here. Now you might say to me, Kate, hello, this is already minusing. It's a minus 5x. Well, guys, think about it. What happens when we have two minuses? If we're going to minus negative 5x or minus 5x, we're basically saying doing the opposite. We're going to do the opposite of subtracting 5x. And so the two minuses together end up giving us a plus 5x. And really what I want you to just see is that this changed signs. Okay, and it's going to continue that way all the way through. All minuses are going to turn into pluses and all pluses are going to turn into minuses. Everything in that grouping will change signs. But then now that you finish that, look at that, guys, super nifty. It looks just like the last one. Yeah, now it's just a matter of combining like terms. And I think we're a little faster now. Let's give it a try. So here's a 2x squared. I can only combine that with other x squared terms. Oh, found one. Negative or minus x squared. So this time, what am I doing? Well, I have 2x squareds. And I'm taking away an x squared. Okay, let me take away an x squared. If I do that, I have just one x squared. Now, you could write this. You wouldn't be wrong, but you'd look a little silly because mathematicians are lazy. We don't bother to count to 1. If there's just a single x squared, we just write x squared. I mean, think how silly you'd look if you ran around going, there's one chair and one table and one, I counted. Yeah, we don't have to say that in English either. We just say chair, table, a couch, And so same thing in math. 1x squared, I'll just write as x squared. Next type of terms. We have a negative 3x or minus 3x. I just read it as negative 3x because it's in the front. Okay, so negative 3x. And to that, I'm going to add 5x. So negative 3 plus 5x. Now, again, do it in your calculator. Okay, guys, we got enough to remember with the algebra without having to deal with the negative numbers. But it's interesting what you're going to get in your calculator. When you do negative 3 plus 5, you're going to get 2. And a lot of students would just shove that 2 right here. But careful, I'm expecting my answers to be terms. I have a bunch of things adding and subtracting right now. And what are you doing with that 2 if you shove it up there? You're making it multiply. I don't want it to suddenly start multiplying, okay? So if you get a positive answer on your calculator, it's super important you put a plus sign. Positive answers are numbers that are adding, terms that are adding. Okay, so I get a positive 2. And positive 2 what? What was I adding and subtracting? I was adding and subtracting x's. They're still x's. Beautiful. And now let's look at our constant terms. Constant, plain old numbers. So I have positive 5 plus 7. You can pick up your calculator if you're feeling brain fried, but I promise you that's positive 12. So you out of your calculator, you'll get 12, and then you just write positive or plus 12. And once again, it is time to stop, y'all. There's the difference between my A students and my B students. They know when to stop. They don't try to mush numbers together that can't be combined. I can only add and subtract like terms, the same kinds of things. All right, cool. I've done adding, I've done subtracting, but now I need you to stop, full stop, take a breath, and realize that the next problem is a different kind of problem. We see these two parentheses shoved together like this with nothing between them, and we are looking at multiplication, which means you need a flipped mindset, guys. We need to go from adding and subtracting mindset to multiplying. Okay, so the rules are shifting. Let's go. We got this. No, I made this one shorter than the last ones because they don't have really long, complicated, ugly ones to multiply in the GED. This is as complicated as we get. Something with two terms multiplying by something else with two terms is as complex as I usually see it. But do remember that when you are multiplying groupings, everything in the first grouping has to multiply with everything in the second grouping. This is when I see that passing out happen. I'm going to see that 3x multiply first with 5x. So first term times first term. So 3 times 5 is 15. Now, notice this is a little different than adding and subtracting. X times x is x squared. You might say, well, why, Kate? That didn't happen when we added and subtracted. No, but remember what exponents mean. Exponents mean that you have the same thing multiplying, not the same thing adding or subtracting, the same thing multiplying. So one way to think about x squared is x times x. Okay, two x's multiplying x squared. Okay, now let's do the next one. 3x times, now watch how I'm going to read this. 3x times negative 7. When you're multiplying and dividing, just read that as negative or positive. So 3x times negative 7. Okay. Again, you can do this in your calculator. You could do the 3 times the negative 7 in your calculator. And if you did, you'd get negative 21. But what your calculator cannot do is algebra. You have to know negative 21 what? So take a look. I had an x here. There were no x's here, so I just have one x multiplying, so there'll just be an x there. Now I'm done passing out the first term, but remember, everything in the first parentheses has to multiply with everything in the second parentheses. Let's pick up my next term in the parentheses, a negative 5, and pass that out as well. Negative 5 times 5x. Again, you can pick up your calculator to do negative 5 times 5, and you'll get negative 25. But you have to see that there's only one x multiplying there, and so there's only going to be one x in my answer. And then almost done passing this out, but I need that negative 5 to multiply with negative 7. Again, you can do it in your calculator, negative 5 times negative 7, but don't start hitting minus. You better do negative 5 times negative 7, and you will get 35. And remember, now I've got these term answers. It's going to be plus 35. You say, well, wasn't I multiplying? Why is there suddenly plus? Yeah, but think about when you multiply multi-digit numbers. You'll get an answer here, and you get an answer there, and then what do you do with them? You add up all your answers. Same thing here, okay? You get all the things you multiply to make, and then they get added up. All right, and now look again. It looks like what I got when I added and subtracted in the second step, that kind of list of terms. And just like with those, now this is just a bunch of things adding and subtracting. And so I can again refer to my combining like term skills. So no wonder you guys kind of get these three things mixed up. The second step's the same for all of them. We do whatever addition or subtraction we can do. Let me do that. I'm going to look for like terms. Now, one thing you're going to notice here, though, is that I only have one x squared term. You know, none of the other ones have an x squared. They have x's, but not x squared. So there's nothing like with x squared. So all I'm going to do is just drop him down. There's no change. There's nothing to combine him with. It's just still in the answer. But I do have a couple of x terms. I have, the first one is negative 21x. And now, because I'm adding and subtracting now, is minus 25x. Negative 21x minus 25x. And again, if you're saying, why are you adding and subtracting to multiply? I'm going to come back to second grade. Our last step of multiplying was adding up all the answers we got. Okay. So anyway, negative 21 minus 25, do it in your calculator if you need to. I get negative 46 and negative 46 what? Well, remember, when you're adding and subtracting, we don't see those x's change. Put that in your notes if you don't remember that, okay? When you're multiplying, that's when we see those exponents start building up, okay? When we're multiplying x's and x's and x's. But when we're adding and subtracting, you will never, ever, ever see a change of exponent. And then take a look, one more term up there, that's that positive or plus 35. It's a constant term, it's a plain old number. There's no other plain old number, so it'll just drop. And again, the difference between an A student and a B student is they know when to stop. There's nothing else we can do here. The only thing left in this expression is that addition and subtraction, and I can only add and subtract the same kinds of things. All right. Wow, we just reviewed so many skills at once. Okay. This video is a review. It's not meant to learn all these things. If you've never done any of this before, go back and just look at the adding, just the subtracting, just the multiplying. Yeah, alone, practice them by themselves. Then we got to get to the stage where they're mixed up, like on a test, and we're not panicked. We know when to do what. All right, guys, super proud of you. If you have stuck with me this long, two things I want to say. First of all, is just a thank you to my patrons and to those of you guys who buy me cups of coffee. You guys are the ones who keep the lights on and keep my fridge full of food for my kids. So thank you guys for your patronage. Thank you for the cups of coffee. You're a blessing. And then I just want to say that if you have any questions about any GED math topic, be sure to drop it in the comments. I'm going to do my best to answer it or see if we can't get it sorted out for you so you pass that test. All right, you guys, happy learning.